In this video, we are going to explore systems of equations in 2 and 3 variables. You have to excuse me because I'm fighting a head cold or a sinus infection or something, so I'm a little nasally today. We're going to solve when we have 2 or 3 equations, and we're going to do linear equations in this video. In the next video, we will do nonlinear, 2 equations, nonlinear. So we're going to start out with some warm-up questions, which is we're going to substitute negative 4y into the second equation wherever I see x. So I'm going to take this negative 4y, I'm going to substitute it in here for this x, because that's what x is in terms of y. So I'm going to get negative 4y minus y is equal to 5. So I'm going to get negative 5y is equal to 5. Divide on both sides by negative 5, I get y is equal to negative 1. If y equals negative 1, then x is equal to negative 4 multiplied by that negative 1. And so x is equal to positive 5. Now, when we are solving systems of equations, as long as it equals a single point, and sometimes it does not equal a single point. Sometimes there's an infinite number of solutions, which means that it is going to be a line in which they intersect, or they're the exact same line. So, or planes, if we're talking about planes, it could be the exact same plane, or they could be where two planes intersect each other at a line. So the way I answer these, if I have an actual answer of a point, I do need to write the answer as 5 comma negative 1. And so that's the answer. On the next example here, we are going to substitute y now as x minus 8 wherever I see y in the second equation. So I have x plus, and then I'm going to replace the y with x minus 8, and it will equal negative 2. So I have x plus x, which is 2x, minus 8 is equal to negative 2. I'm going to add 8 to both sides, so 2x is equal to 6. So this tells me that x is equal to 3. Now I need to substitute that back into this equation to solve for y. So y is equal to that positive 3 I just found, minus 8, because that's the replacement for x. So y is equal to negative 5. So my answer as ordered pairs would be the x part first, which is 3, and then the y part, which is negative 5, and that would be my location in which those two lines actually intersect on the xy plane. Okay, so now I'm going to go ahead and do this next substitution. Wherever I see x here, I'm going to replace it with this entire value. So I have 2 multiplied by negative 2y minus 7 minus y is equal to 1. So now I'm going to distribute the 2 through. So I got negative 4y minus 14 minus y is equal to positive 1. Negative 5y minus 14 is equal to positive 1. I'm combining up like terms, moving the 14 to the other side. So I get negative 5y is equal to 15. So y is equal to negative 3. Now I need to substitute that back into the first equation where I have x is equal to negative 2. My y is negative 3. And then I have minus 7. So x is equal to positive 6 minus 7. So x is equal to negative 1. So my answer as ordered pairs is negative 1 comma negative 3. So when we are solving systems of equations where we have just two systems, two equations of lines, we have the 3 choices here, which is it actually intersects at a particular point in space. Your 2 lines could be parallel, so there'll be a no solution, or they could be the exact same line, and that means that there is an infinite number of solutions, which is the equation of the line is a solution. So when you have one common point, it'll be the x comma y. If you have 2 parallel lines, the answer would be either the empty set with brackets, empty brackets, or this 0 with a slash through it means empty set, or you might, in the homework, write none. Then if it is the exact same line, we're doing something called parameterization, which means I'm going to let x be x and y is in terms of x, or I might let y be y and then x is in terms of y. It just depends on how you want to write the parameterization. If we're in the land of 3 variables that are linear, x, y, and now z, you are going to have the option of having a single point, which will be the ordered triplet x, y, and z, or you're going to have a line in which 2 of the planes may intersect. You may have a line where 3 of the planes intersect, and it intersects as a line. In this case, we parameterize, we let z be in terms of itself, and then x and y be in terms of z. And we have an infinite number of solutions. This is called parameterization. And of course, we can have the exact same plane again, and then a single point where the 2 planes intersect. So here we go, where we have the no solution. This is a no solution because this plane that is red intersects this plane that is green as a line. The red and blue intersect right here, and then the blue and the green intersect, so they all intersect but not with each other. Here's an example in which the blue plane and the green plane are running parallel, and they both intersect a single plane, which becomes lines. And in these 2 cases, in this final one, which all the planes are parallel, are no solutions. So we'd either write none, or with these brackets that are empty, these funky brackets, or the 0 with a slash, which means empty set. Now, when you're asked to find the solution, you're trying to find the point in space in which these 2 lines or these 3 planes intersect. If they intersect at a very nice place, then you can do it graphically. So as an example, I'm going to do x plus y is equal to 2. I'm going to rewrite this in the form that we're most familiar with, which is y is equal to. That way I can have my intercept and my slope, and so it's negative x plus 2. And I'm going to go ahead and graph this. So at positive 2, and then I'm going to go down 1 over 1, so it is a down and then right 1. And let's see if I can draw this line nicely. Unlikely, but I'm going to give it a go. Let me see. Should have put my glasses on. Anyways, I'm going to do it the best I can. So here's this line. And then the second equation is I'm going to rewrite this as y is equal to negative 3x plus 0. So we know that it's crossing right here. And I'm going to go down 3, or in this case I'm going to go up 3 and right 1, which is right there. And so graphically, and if you close your eyes, these are perfectly straight lines. Well, if you kind of squint or you need glasses, then these might be totally straight lines. And you can see but graphically that this is going to intersect at negative 1 and positive 3. Now, I can do this also by substitution or elimination. So by substitution, I'm going to substitute this in wherever I see my y. So I'm going to get negative 3x is equal to negative x plus 2. So I end up with negative, adding x to both sides, negative 2x is equal to 2. So x is equal to negative 1, which is what I have right here. And then substituting that back into this equation, I get the positive 3, which is right here. Okay, so let's take a look at the next example. And again, this is only when the lines intersect in an integer value for x and y. You can just figure it out by looking at the lines. So if I take a look at the next set of equations, I have y is equal to 2x minus 1. So I'm going to go to negative 1. Up 1, right 1, up 1, right 1, and let's see if I can draw this fairly okay. So there's my first equation, and I'm going to do the same thing here. Y is equal to 2x plus 1. Oh, yeah, see, these aren't going to intersect at all because their slopes are the same. So for this one, we have a no solution. So I'm either going to write it with the curly brackets, or I'm going to write it with a 0 with a slash, which means no solution, and that's because I have parallel lines. And I can see that based on the slopes and the intercepts are different. Let's take a look at my next example here. I'm going to solve for y for the first equation. When I solve for y, I'm going to get y is equal to 1/2 x minus 1/2. I'm going to take my second equation and solve for y. So I'm going to get 3x minus 3 is equal to 6y. Now I'm going to divide each side by 6. And dividing each term individually by 6, I get 1/2 x minus 1/2 is equal to y. And these two are the exact same equation. So I have an infinite number of solutions. And so I'm going to go to negative 1/2, and here's a negative 1/2. I'm going to go up 1 over 2, and up 1 over 2, get another point. So there it is. And the way I would answer this is two ways. Either I'm going to write this as x and then 1/2 x minus 1/2. So I've parameterized the y value, or I could parameterize the x value in terms of y, which means I would probably take this equation right here and write this as 2y plus 1 is equal to x. And then I could answer it as 2y plus 1 and then comma y. Now either one of these would work. They're both parameterizations because I have a single line, and so these two lines, which are the same thing, are going to intersect an infinite number of ways. So the substitution method is what we did when we first started out. And basically what we do is, if we solve for one variable and shove it into the other and then solve. Now, when you're in 2 variables, it's not too bad, but when you're in 3 variables, it's way harder. I mean, it can be, well, it's not harder, it's just cumbersome. The other way that we can, sorry, is the Gaussian elimination, which means I start eliminating variables so that I get down to, with 3 equations and 3 unknowns, I'm going to get down to a single equation, or a single variable is equal to a single number. And this one is actually, for most people, much faster and less cumbersome. And what I can do is I can interchange the order of 2 equations. So if the first equation I don't like, I can put it down to the third, etc. I can multiply both sides of an equation by a non-zero constant, and I can add non-zero multiples of one equation to another. Here are the steps. And so I'm going to do this by the elimination method. Now, here's what I do when I do the elimination method, is I look to see which one is the easiest to do a multiplication by. So I could eliminate the y's, but if I eliminate the y's, I'd have to multiply this first equation by 5 and the second equation by 3, so these coefficients match with opposite signs, and then I would add the 2 equations. Now, I don't feel like doing a multiplication, both equations by a multiplication of a 5 and a 3. So I'm going to eliminate my x's here. So I'm going to multiply this top equation by not only a 6, because I want the coefficients to match, but a -6, because to eliminate, we want to have coefficients matching with opposite signs. So I'm going to denote it like this. I'm going to just put parentheses all the way around, and I'm going to do a -6. And then I'm going to do an arrow, because it's not necessarily equal, because I am doing 2 things at once, which is I'm multiplying a -6 through the first equation, which gives me -6x plus 18y is equal to -12. And then the second equation, since I didn't do anything with it, I'm just going to rewrite it. 6x plus 5y is equal to -34. Now I'm going to add these 2 equations, and these go to 0, which is really lovely. Then I'm going to add my y's, and so I have 18 plus 5, which is 23. And then over on the other side, I'm going to add a -12 and a -34, which gives me a -46. Dividing both sides by 23, I'm going to get y is equal to -2. Now, I still have to back substitute into one of the 2 equations. I'm going to back substitute into the first equation, because it looks like I'll have x already. So I go back to my original equation, which is x minus 3 multiplied by a -2 is equal to 2. So x plus 6 is equal to 2. So x is equal to negative 4. So my answer is an ordered pair, negative 4, comma, negative 2. There's my answer. And I try to do, when I do the elimination, is I try to only multiply one equation by a number. Sometimes you're stuck with 2, and that is what it is. So I'm going to go ahead and take the second, and I look at this second example here. I'm going to multiply the first equation by a negative 2, because if I get this coefficient on the y to be a negative 2, it will cancel with a coefficient here. So I'm going to use an arrow showing I've got negative 4x minus 2y is equal to negative 2. And then my other equation did not do anything, so I have 3x plus 2y is equal to negative 2. I'm going to add these two together. This goes to 0, and I get negative x is equal to negative 4, so x is equal to positive 4. Now I still have to back substitute. I'm going to back substitute back into the first equation because it'll be easy to solve for y. So I have 2 multiplied by that 4 plus y is equal to 1. So I have 8 plus y is equal to 1. So I get y is equal to negative 7. So my answer is 4 comma negative 7. On this equation, I'm going to, or in this example, I am going to multiply the second equation by a number 4, because then I'd have the coefficients to be opposite and the same. Opposite signs, the same 4s. Yeah, not feeling terribly well. So hang with me. So 4x minus 8y is equal to 12. And the second one is going to be negative 4x plus 8y is equal to negative 12. When I add these together, I get 0 is equal to 0. So what does that mean? Well, that means that they are the exact same line, which means I have an infinite number of solutions, because this is a true statement. When I end up with a true statement, it's an infinite number of solutions. When I do the elimination, and as an example, I haven't got it yet, but as an example, if I would have had, when I did my plus, and I ended up with 7 is equal to 0, this is a false statement. So I have some equation here, and I had some equation here, and I get the number 7 is equal to 0, or something, some number other than 0 is equal to 0. When this happens, this is a false statement, so there is no solution. So in this case, I would either write the empty set or these curly brackets that are empty, or it depends on the homework, it may say none. But going back to this example, since these are the exact same lines, then I'm going to parameterize either the x or the y. If I parameterize x, I'm going to take this equation and solve for x. So negative x is equal to negative 2y minus 3. X is equal to 2y plus 3. And so I have 2y plus 3 comma y. I could have also solved for y, and then I would have had x comma, and then whatever the equation would have been in terms of y. Now on this, what I'm going to do is when I do elimination with 3 variables, I try to get the first equation, the top equation here, to be a 1. And the reason it is because I can multiply this top equation by whatever I need to eliminate the x's. Now if that doesn't happen, that it doesn't happen, but that's what we hope to do. So I'm going to go ahead and multiply this first equation by negative 2. So this becomes negative 2x minus 6 times 2 is negative 12y minus 6z is equal to negative 8. Then my second equation did not do anything, so I'm going to do 2x plus y plus 2z is equal to 3, and I'm going to add these two equations. When this happens, those cancel out, so I get negative 11y minus 4z is equal to negative 5. Got to check my math. I am feeling sketchy today. Now, I'm going to do this a second time, but now the second time, what I'm going to do is I'm going to multiply the top equation. So what I did to get to this point is I took equation 1 and multiplied it by a negative 2, and added it to equation number 2. Now I'm going to take the top equation and multiply by a negative 3 and add it to equation number 3. When I do that, so I'm going to take this and multiply now by a negative 3. I'm going to get negative 3x minus 18y minus 9z is equal to negative 12. The third equation is just going to be 3x minus 2y plus z is equal to 0. Now I'm going to add these two together, and I'm going to get negative 20y minus 8z is equal to negative 12. Now I have just these two equations that are in just two variables, so I'm just going to rewrite them over here. So I'm going to call this equation A. So equation A is negative 11y minus 4z is equal to negative 5. And I'm going to call this equation B. So equation B is negative 20y minus 8z is equal to negative 12. So now I'm going to work with just these two equations, and I'm going to eliminate the z's because if I multiply this by a negative 2, it'll make the easiest multiplication. So this is going to be positive 22y positive 8z is equal to a positive 10. The other equation did not change, so negative 20y minus 8z is equal to negative 12. I'm going to add these two together. These eliminate. That gives me 2y is equal to negative 2, so y is equal to negative 1. Now I'm going to put this negative 1 into one of these two equations. It doesn't matter. Looks like this is just as easy. So I have negative 20. Actually, let me use the same color. Excuse me. Negative 20 multiplied by negative 1 minus 8z is equal to negative 12. So I have positive 20 minus 8z is equal to negative 12. So negative 8z is equal to negative 32. So z is equal to 4. Okay. So now I have z and y. I need to put that back into the original equation, one of them. So I'm going to put it back in the first one, which is this one right here. I'm just going to write it over here, x plus 6y. So I have x plus 6y plus 3z is equal to 4. I'm going to go ahead and put in my y's and x's. So x plus 6, my y was negative 1. Plus 3, my z was 4 is equal to 4. And so I have x minus 6 plus 12 is equal to 4. So x plus 6 is equal to 4. So x is equal to negative 2. So my solution is negative 2, negative 1, and 4. Because remember, it has to be x, y, and z in that order. And so there is my solution. Let's do the next one. So again, what I'm going to do is label these 1, 2, and 3. I'm going to take and multiply negative 2 by equation 1 and add it to equation 2. So I'm going to have negative 2x minus 2y minus 2z is equal to negative 12. And I'm going to have 2x minus y minus z is equal to negative 3. When I add those together, that eliminates. So I get negative 3y minus 3z is equal to negative 15. I'm going to do equation 1 with a negative 1 times equation 1 plus equation 2. And so I have negative x minus y minus z is equal to negative 6. And my equation 3 is x minus 2y plus 3z is equal to 6. I'm going to add these two together. That eliminates. I get negative 3y plus 2z is equal to 0. Now I have this equation I'm going to call A, and I have this equation I'm going to call B. So I'm going to add A plus B. So equation A is negative 3y minus 3z is equal to negative 15. And then I have negative 3y plus 2z is equal to 0. And actually I need to multiply a negative 1 times a so that we can have elimination. So that will be a negative, that will become positive, and that will also become positive. When that happens, my y's disappear, and I get 5z is equal to positive 15. So z is equal to 3. Once I have z, I'm going to plug it back into this equation and plug it back into b. And well, I could have plugged it into a. B is just as easy. So negative 3y, negative 3y, plus 2 times 3 is equal to 0. So negative 3y is equal to negative 6. Y is positive 2. So now that I have y and z, I'm going to put it back into the first equation, which was x plus y plus z. So x plus y plus z is equal to 6. This is equation number 1. So I have x plus 2 plus 3 is equal to 6. So x plus 5 is equal to 6. So x is equal to 1. So my answer is 1, 2, 3 as an ordered triplet, because remember it needs to be x, then y, then z. Now let's do this last one, and then we have one application to do. So again, I'm going to label these 1, 2, and 3. So I'm going to do negative 3 times the first equation plus the second equation. So negative 3x minus 9y minus 12z is equal to negative 3. My second equation is just 3x plus 4y plus 5z is equal to 3. Now I'm going to add these two together. My x's cancel. I get negative, what do I end up with? Negative 5y. And then this becomes negative 7z is equal to 0. I'm going to take negative 1 times equation 1 plus equation 2. So I have negative x minus 3y minus 4z is equal to negative 1. That's my first equation multiplied by negative 1. X plus 8y plus 11z is equal to 2. I'm going to add these two together. My x's cancel, and I get negative 5y. This becomes minus 7z, and this becomes 1. So I'm going to call this A, and I'm going to call this B. So I'm going to take negative 1 multiplied by A plus B. So I'm going to have positive 5y plus 7z is equal to 0. And I'm going to have negative 5y minus 7z is equal to 1. And then what ends up happening is that these both become 0. So I get 0 is equal to 1. This is a false statement. This is not true. This is never true. 0 does not equal 1. So that means we have no solutions here. And we either write the empty set like that, or you write the word none if it's in the homework. So let's take a look at the next two. Again, I have equation 1, 2, and 3. Now this time, since this equation, the third equation, doesn't have a z, I'm just going to use these two equations to eliminate the z, and then I'll have an equation just in terms of x and y. So I'm going to go ahead and just add equation 1 plus equation 2. So I have x plus 2y minus z is equal to 4. And I have 4x minus 3y plus z is equal to 8. And so these eliminate. So I get 5x minus y is equal to 12. Oh, but that is equation 3. I'm going to call this A. So I'm going to get A is plus B. Actually, negative A plus B. I'm going to get 5x minus y. Negative 5x plus y is equal to negative 12. And then I'm going to get 5 x minus y is equal to positive 12. And so what this tells us is 0 is equal to 0. So we have an infinite number of solutions, so we need to parameterize. And by convention, what I should have is I should have here some function of z in the x position, some function of z in the y position, and then z in the z position. So z is going to be equal to z. I'm going to take the third equation. So the third equation was 5x minus y is equal to 12. And I'm going to solve for y. So I have 5x minus 12 is equal to y. Now I'm going to put this into my first equation, and I'm going to solve for x in terms of z. So x plus 2y, we have a value for y. Y is going to be 5x minus 12. And then z, so minus z is equal to 4. So I'm going to have x plus 10x minus 24 minus z is equal to 4. So I'm going to move everything but the x's to one side, so I get 11x is equal to a positive z plus 28, adding 24 to both sides and adding z to both sides. So x is going to be z plus 28 over 11. So here's what I'm going to put in over here, which is terrible, but that's just the way it is. And then I'm going to take and replace this x and put it in right here. So I have 5. I have z plus 28 over 11 minus 12 is equal to y, and that's going to go in right here. So my answer, which is terrible, z plus 28 over 11, comma, 5, z plus 28 over 11 minus 12, and comma, and then z. And so here it is, we had to parameterize because we had an infinite number of solutions. Now I'm going to go ahead and let you do h and I, since I've shown you what happens when we have nice numbers, when we have no solution, and when we have an infinite number of solutions. So for h, hopefully you found a false statement, and so we know this one is a no solution. And we either do the curly brackets that are empty, or a 0 with a slash through it, which means empty set, or you write the word none if that's what's required in the homework. Then with question 11, or 11I, I guess, question I, you should have got the ordered triplet 0, 2, and 1. So that's those solutions. Now, there is applications to this. We're going to look at 1 8-ounce serving of each brewed coffee, Red Bull energy drink, and Mountain Dew soda. All three of them contain 197 milligrams of coffee. So I'm going to start with my variables. So x is coffee. Y is Red Bull. And z is Mountain Dew. Now, you can, of course, write this as C, an R, and an M, because that would actually make more sense, and you can totally do it that way. So we know that this XYZ or CRM represents the amount of caffeine. Amount of caffeine. Excuse me, I'm sorry. Caffeine. INE. Okay. So we have C plus R plus M is equal to 197 milligrams. One serving of brewed coffee has 6 more milligrams than 2 servings of Mountain Dew. So if I take Mountain Dew, it has 2 servings of Mountain Dew, and 1 serving of brewed coffee has 6 more. So if I take Mountain Dew plus 6, I'm going to get the coffee, because coffee is 6 milligrams more than 2 servings of Mountain Dew. 1 serving of Red Bull contains 37 milligrams less than 1 serving of each brewed coffee and Mountain Dew. So then what this would be is the Red Bull is equal to the coffee plus Mountain Dew minus 37, or you could have said Red Bull plus 37 is equal to the coffee plus Mountain Dew. It would not have mattered. Either way, what I'm going to do is I'm going to go ahead and solve, or put all the variables to one side and all my non-variables to the other on this equation, which gives me C minus 2m is equal to 6. So C minus 2m is equal to 6. And then this one, solving or getting all the variables to one side, so I have C plus m minus r is equal to 37. So C minus r plus m is equal to 37. Now notice you're going to want to put the variables in the same positions because it'll just make it easier later. And so I'm going to let you solve this, and hopefully what you got is the caffeine is 80 milligrams. The Red Bull is 80 milligrams. And the last one, which is Mountain Dew, hopefully you got to be 37 milligrams. And that is it for this video.